Hi, and welcome back to The Joy of Ray Tracing, a video series in which we make several ray tracers from scratch. On the last episode, we saw how to get into the JavaScript console inside your browser, and then once we were in the console, we took a tour of the JavaScript programming language. And although that video turned out to be much longer than I had anticipated, sorry about the length of that one, hopefully you were able to get a basic understanding of how the JavaScript programming language works and how we can use JavaScript in the browser to make our web pages more responsive and interactive. But today's episode is all about GitHub, and in particular, I'll show you how to make your very first repository on GitHub so that you can easily share your ray tracing projects that we'll be working on this video series with others online. I'm going to go through all the steps on camera here today so that you can see how to create a GitHub account as well as create your very first repository on GitHub. And we're going to do that using a new feature of VS Code which integrates GitHub into the environment of VS Code, so you can actually make your very first repository without even leaving the environment of VS Code. Then once we have our first repository set up on GitHub, I'll show you the basics of GitHub and how it works, and also how to maintain and update your repository over time. And finally, we'll see just how easy it is to push changes from your code up to your repository on GitHub. So here's what we're going to do today. Today's to-dos. First, we'll go over what is Git and what is GitHub, and how are the two related and how are they different, and why we would want to use GitHub for our projects in the future. In order to use the latest feature from VS Code which integrates GitHub into VS Code, we'll have to download and install Git. And in case you're new to Git and GitHub, I'll walk you through the steps of creating a new account on GitHub. Once we're signed in to our new GitHub account, we'll see just how easy it is to use VS Code to create our first repository. And literally, it just takes a couple of clicks and you've created your first repository. Then we'll visit our newly created repository on GitHub, and I'll show you some of the basics of how GitHub works so that you can add to and maintain your repository over time. Also, we'll take a look at one of GitHub's greatest services, and that's called GitHub Pages. And that offers to host any projects that you want on GitHub for free. And finally, to test that everything's working, we'll go back inside VS Code and make some changes to our web page, such as adding a button element to the page, as well as randomizing the width and height of the rectangles that are displayed on screen. And then you'll see with just a couple of clicks, we can push those changes to our remote repository on GitHub, and it really is that easy. So I'm super excited to show you that today. So let's get started. So I'm going to go into my browser. And first, let's talk about what Git is and what GitHub is. So if I just do a Google search of Git, we see here that Git is a free and open source software for distributed version control, tracking changes in any set of files. So basically, Git is a system for tracking changes in your code over the lifetime of your project. It is what's called a version control system, or VCS. And there are other options out there for version control, such as Subversion or SVN or Perforce or Mercurial. But over the years, Git has sort of risen to the top in popularity and use because of its speed and its efficiency. So you may be asking, why would I even need version control for my projects? what's the advantage? Well, say you had a project that you were working on which had several source code files, and over time the project grows and grows, and the number of lines of code also increases. Now let's say when you're deep into the project, you realize that there's a bug that crashes the whole thing, and you don't know why the program is crashing and when or where that bug was introduced into your code. So for very small projects, you can just use the undo button or Control-Z on most software, and you can get back to a previous state. But if your project has more than a trivial amount of code, how many times do you need to press the undo button to get back to a previously working version of your code? And there's where the word version comes in. So often we'll say something like, I wish I could just get back to the previous version of this code that was working, and then maybe I could figure out where the bug was introduced. And so that's where version control systems come into play. A version control system like Git tracks changes to your code over time, and it actually takes virtual snapshots of your entire code base each time you commit or save a new version of your code. So with Git, you can go back to a previously working state of your code and then just continue from there, and then try to find out where you introduced the bug, or maybe branch off into a different direction, knowing that you at least have something that's working that you can build upon. With Git, there's a notion of a repository for your project. So usually for each project that you're working on, you have a folder containing that project, and the repository encompasses that entire folder. And then as you're working on your projects inside of your code editor like VS Code, Git quietly runs in the background and listens for any changes to your code base, no matter how small. So let's say on a particular day that you make some changes to your code, Git will listen for any of those changes, and then when you're done for that day, it will ask you, do you want to commit these changes to the history? And so if you say, yes, I would like to commit those, I feel good about what changes I made today, then Git will take a snapshot or a virtual snapshot of your entire code. And so that snapshot captures the state of your code at that particular moment and freezes it in time, essentially, so that in the future you can refer back to it if you need to. Git itself is a fairly mature technology. It was released back in 2005 by Linus Torvalds, the same Linus Torvalds who is famous for developing the Linux operating system. Back then, Linus only intended for Git to be used with a CLI or a command line interface. And that essentially means that you use Git on your system through a series of textual commands inside of a command line. And therefore, we didn't even have a GUI or a graphical user interface to interact with Git. Now, a couple years later, around 2008, we see the emergence of GitHub. And so GitHub takes that notion of the Git repository and places everything online in the cloud. And so GitHub enables you to host your Git repositories online. So let's just take a quick look at an example repository on GitHub. So I'm just going to go to my repository called three.js path tracing renderer. And so this entire repository is hosted for free on GitHub. You can see the URL github.com/myname or my username, and then the project. So by hosting repositories online in the cloud, GitHub introduces a social element to repositories and software development in general. So since my repositories are hosted on GitHub, I can share demos online with anyone who visits this page, and all they have to do is click once and they're seeing the demo. So for instance, let's click on Cornell Box which renders the famous Cornell box in real time. You can see it's running at 60 frames per second, real-time path tracing. And if I click anywhere, it's interactive. I can move the camera and fly through the scene. And then let's say you wanted to look at the code for that. So you just find Cornell box.html. And here's the web page shell that we were discussing earlier. So you can see the head element here and the body element. And the body uses a number of JavaScript files. And so if you wanted to dive into it further, you could find cornellbox.js. So you go under the JS folder and look for Cornell box. There it is. And that's the JavaScript required to get this demo running. And the main path tracing or ray tracing work is being done in this file here, Cornell box fragment.glsl, which is short for Cornell box fragment shader. So we can go into the shaders. So now we go into the shaders directory and find that file. Just look for Cornell box. And then you can see how the magic is done. So this is the bulk of the rendering code that actually puts the graphics up on screen. And if you go under my name here and you click on repositories, it'll show you all the repositories that I have hosted on GitHub for free. And one more thing to mention is that since GitHub takes the Git repository and moves it to the cloud online and makes it publicly viewable, it opens up the door to collaboration on software development. So especially if you're part of a team of software developers and you're all working on the same project, it really helps having the project hosted on GitHub, because then everyone on the team has access to the state of the project at that moment. And since GitHub uses Git under the hood, they can also go back in time and see a snapshot of the entire code base in case they need to investigate an introduction of a bug or another error in the code base that's causing an issue in the current code base. And since GitHub brings your repositories online where other people can see them, you essentially have more eyes on your code, which helps in certain situations. And so I'll give you an example. On my path tracing renderer project, if I look at pull requests, now a pull request is a request to pull in changes from another software developer who has access to your code. So if I go under pull requests and I go under the closed pull requests that are from the history, you'll see this pull request called Fix Black Screen in Chrome. So if I click on that, this developer had noticed an issue in my code. And if you click on the issue, it says when I run your demo, it gets a black screen and nothing shows. What happened? And so I didn't really know what was going on, but then they figured it out and offered a quick fix for this issue. And if you go under Files Changed, you can see what they wanted to add or delete from my code base. And as you can see, all that changed is one little number. So I had a 0 here for the alpha component, and that turns out to be black. And that's why the screen was showing up black for many users. And so all they did was switch that to a 1. But I didn't know what was causing that. And I didn't even think to look in this spot in the code because my code base was quite large at that time. So the bug could have been in many different files all throughout my repository. So this is one instance where having more eyes on your code and having people offer suggestions and fixes for your code really helps. I guess I would have eventually found this on my own, but who knows how long that would have taken. So having extra eyes on your code like this and having people offer suggestions and fixes in the form of pull requests, or PRs as they're known as, is really great to have. So to wrap up Git and GitHub, Git is the underlying technology that tracks your source code over time. And so it listens for any changes, and when you commit something, you save a virtual snapshot of your entire code base at that moment in time that you can refer back to at any moment in the future. And in Git, you work inside what is known as a repository, and that's usually under the same folder for the entire project. Now, GitHub takes that notion of a repository or that folder and places it all on the cloud, and then it hosts your project for free on github.com. And as we just saw, that opens the door to easily sharing your projects online, as well as remote collaboration among software developers all on the same project. So you can have Git without GitHub, so you can have Git running on your system, tracking your software source code over time, but you can't have GitHub without Git. So GitHub has Git running under the hood and powering all the repositories that are online. And finally, one of the major differences between the two is that Git is primarily used in a command line interface, or CLI. So that means just typing text commands in a command line, versus GitHub, which offers a graphical user interface, or GUI, which means you have nice visual buttons to click on, and the notion of tabs and windows inside of github.com's website so that you can see and work with the different components of Git, which is the underlying technology that powers GitHub. So let's take a moment and open up Visual Studio Code. I just want to show you something real quick. So over here on the left side of Visual Studio Code, you may or may not see a source control option. And so if you don't see any source control icon, then right click and then check source control. You can also get to it by view source control. So right click on this side menu bar here and then check source control. Click that. And now you'll see this icon pop up that's called source control. So that will use the Git technology under the hood. And it says here you have to install Git because I don't have Git on my system right now. And since this is a fresh install of VS Code, and since I wanted to show you all these steps today, I purposely did not install Git on this machine yet. And so it says, do you want to download Git for Windows? And so we can click on that, but let me just show you how to easily get that online. So let's go back. And again, just do a Google search for Git. And it should be the first option. So it's git-sh SCM, which stands for Source Control Management.com. And so we click on that. So in order to use GitHub and have our code and our projects hosted freely on GitHub, we need to install Git first, which is the underlying technology. So if you're on another system besides Windows, this might look a little different, but I'm just going to click download for Windows because I'm on a Windows device. And then it says click here to download the latest version. So I'm going to click there. Okay, and then click on the executable. Now, the hardest part about installing Git is the tiredness that your mouse finger will experience clicking on all the next buttons on the setup wizard. I think Git must have the world record for the number of clicks on the next button for the installation to happen. So let's see that now. Next. It's fine where it wants to install. Next. Yes. This is all fine. Next. That's good. Next. Since we have VS Code installed, we can change this to use Visual Studio Code as Git's default editor. Next. Let Git decide. That sounds fine to me. Next. Recommended. Next. It's bundled. Okay, I don't know what that means. Next. Use the library. Okay, next. I wasn't kidding when I said we're going to have to click next a lot. So check out Windows style. Okay, next. Whatever that means. Default terminal. That's fine. Next. Default. Next. Git credential manager. Okay, next. Enable file system caching. That sounds good to me. Next. I don't want to enable any experimental options. So finally, oh, I thought we'd never see it. Here's an install button. So joyfully click on install. I think I counted about 15 next buttons there. And I don't need to view the release notes, so uncheck that and then click finish. Whew. Let's give our poor mouse fingers a rest, shall we? One way of finding out if you have Git correctly installed on your system is to go into the command line. And so on Windows, that's just cmd. And the app command prompt should pop up. So click on that. And now if you type the words git space 2 dashes, so minus minus, and then version, it should give you the version of Git that you just installed. And there it is. So that means it's correctly installed on our system. And the version is 2.38.0 on Windows. So let's see if that's the case on the website. Yes, 2.38.0. So we're good to go so far as Git is concerned. Now from here on out, we're never going to interact with Git at all. We're not going to use the command line. We're not going to use any terminals or textual commands. It's all going to be through the easy buttons of VS Code and the GUI inside of GitHub.com's website. So you can X out of here. Let's go back into VS Code. And if you notice, there's a little person icon and it's called accounts. If you click on that, it says you are not signed in. So I purposely signed out of everything for this video so I can show you how to set all this up on camera. So what we're going to do now is we're going to create an account so that we can sign in right here on VS Code, and that will connect Git that is now installed on our system and GitHub, which is online. It'll connect the two and then be able to create the repository online for us, as well as make changes to the code that we make here in VS Code. It'll push those changes up to the cloud. So that's really cool. So the very next thing we need to do is create a new account on GitHub. So let's go to GitHub. So you can just Google GitHub. And it should come up at the top. So just click on github.com. And you'll be taken to their landing page, which shows the planet Earth and all the repositories online and all the collaboration going on. So down here in the left bottom corner is sign up for GitHub, and you can put your email address here. Now, if you already have a GitHub account, you obviously don't need to do this, but for those of you out there who might have not used GitHub before, I wanted to show you exactly what you need to do in order to get your account up and running. So let's click on sign up for GitHub. Welcome to GitHub. Let's begin the adventure. Okay, so it says enter your email. So I'm going to type my email address that I want to be associated with this account. And then hit the continue button. Now it asks you to create a password. Since GitHub is so widely used and so popular, security is a concern, so you should pick a strong password. And it'll let you know if your password meets its security requirements. And now when I've entered my desired password, it says my password is strong, so that's a good sign. Continue. Now enter a username. So this name will be the username that's displayed on all of your repositories. So on my other account, I have ERICHLOF, which is a shortening of my full name. But for this one, I'm going to call it, after this series, Joy of Ray Tracing. And then hit continue. See, would you like to receive product updates and announcements via email? I usually put no for this, but you can choose what you want. Continue. Okay, so the username that we picked checked out. No one else was using that username. And then now it wants to verify my account. So please solve this puzzle to verify that you are a human. Do you want to play a game? Yes. Click Start Puzzle. Okay. Pick the spiral galaxy. Well, you know, considering the advancements made in AI recently, I don't know how much longer these little games will be able to filter out the computers versus the humans. So click the spiral galaxy again. That was a fun game. And then now if you scroll down, it says create account. So click on that. You're almost done. We sent a launch code to your email address. Okay. So I'm going to go check my email, and I should have a launch code in there. So there we go. And now I can just select that. Go back to the website. And once I pasted the numbers into there, it went to this page. So it says, "Welcome to GitHub." So I guess that worked. How many team members will be working with you? Well, just me. Are you a student or teacher? No, not at this point in my life. So continue. But I am a lifelong student of ray tracing. So I guess I could say I am a student in some respects. What specific features are you interested in using? So at this point, we just want the basic account to be able to put up our repos online and have them hosted for free by GitHub. So just click continue. And now it brings you to the plan options page. And so we want the free option here. I guess if you were a part of a larger team that required more features, that you could select this one, but you would have to pay for that. So let's continue for free. Oh, that's a cool animation. Okay, great. I think everything is set up now. So it asks you if you want to create a repository, and I see a notification over here. Feature preview. Let's see what that is. Well, we don't really need any of these for now. Let's click out of there. So if you click on this little bitty icon in the top right corner, you can see I'm signed in as Joy of Ray Tracing, and now you can click on your profile. And these images are computer generated, so I have a different one for my other account on GitHub. So you can edit the profile, and you can put your name. So I'm just going to say Joy of Ray Tracing. Add bio. This name is used for demonstrating a creation of a new account on GitHub. You can put your company, location, if you have a website, if you have Twitter. So for now, this is fine. We don't need to dwell on this too long. So save. And if you click on your profile picture, you can edit the profile picture itself. You can put a picture of yourself in there if you like. And you can set a public email if you want. So people looking at your projects can contact you if they need to. So we'll go back. And now up at the top here, it'll show you the overview, repositories that you have, projects, packages, and stars. So repositories are what we were talking about earlier with Git. So you make a repository and then you put that online here on github.com. And so it says Joy of Ray Tracing doesn't have any yet because we haven't created a repository, but we're about to do that in a minute. So I'm excited to show you how easy that is. So projects, I don't really use these two, projects, packages, and then stars. These are like bookmarks of repositories that you find interesting that aren't your own. So for instance, if we search GitHub, go in the search window here and type three.js, and don't don't click in this user, but rather all GitHub. So I want to search all of GitHub for the three.js repository. And there it pops up at the top, Mr. Doob 3.js. So you click on there. And then here's the repository for three.js. And then if you like this repository or you're interested in bookmarking it, just click the star button and then it'll say starred. And now when you go back to your profile page, let's click on the little icon here and go back to your profile. Now it says I have 1 star. So you click on stars and then it reminds you what you had been interested in. So here's the three.js library, and then we can click from here and go right to it. So it's kind of like a bookmark system in GitHub. And you can see by the number of stars that three.js is quite popular. It has almost 86,000 stars. So 86,000 people said that they liked this repository or that they were interested in it or it benefited them somehow, and they clicked star that repository. One final thing before we go back to VS Code and actually create the repository is that I can't stand the light theme of most websites, so I prefer a dark theme. And so let's go under here and click on Settings, and then click on Appearance. And then instead of Sync with System, click on Single Theme. And I really like the dark dimmed option way down here on the bottom right. So click there. Ah, much better. That's much easier on my eyes and your eyes too, watching this video. So now we can go back to your account. Now we're going to leave github.com for a moment and go back into VS Code. So minimize that. All right, let's return to Visual Studio Code. And then you'll notice over here it says, after installing Git, please reload. So let's click on Reload. And now that we have Git installed on our systems, these options show up. The first option allows you to initialize a repository locally for this folder. And so that would be a classic use of the Git system. But the second option is the one we want. It says you can directly publish this folder to a GitHub repository. And so for those of you out there who are new to all this and Git and GitHub and VS Code integration of GitHub, this little button right here saves you a whole lot of time. Back in the old days, we had to manually create our repositories on the github.com website, but some of that process was not very intuitive, and there wasn't a lot of videos back in the old days about how to do that. And so the fact that VS Code even offers this option is a really cool feature. So click Publish to GitHub, and when we click this button, it's going to create a GitHub repository for just this project. So a dedicated repo on GitHub for us, and it'll initialize it and everything. And so let's click Publish to GitHub. Now it says the extension GitHub wants to sign in using GitHub. So click Allow. And it says allow an extension to open this URI. And you can say don't ask again and then open. And then it'll ask you to sign in to your GitHub account. So enter the information that you had used to create your account on GitHub. and then click Sign In. And then this page is asking you to authorize the Visual Studio Code application to be able to use GitHub features. So authorize Visual Studio Code. And now back in VS Code, these options pop up here, and you should see your account name that you picked. So in my case, it was Joy of Ray Tracing, and then it wants to call it Ray Tracing Projects. And if you recall, that was our folder name for this entire project that we've been working on. It was called Ray Tracing Projects. So that's really cool. Everything's filled in for you, and now you just have to decide if it's going to be private or public. And so in order for GitHub to host your repository for free on GitHub pages, which I'll show you in a minute, you have to make it a public repository. In other words, have it where other people can look at your source code. And so we're going to click Public. And then it asks you, do you want to include all the subfolders in your project? And typically this is yes, you just leave them all checked. But if for some reason you didn't want to include a file or a folder, you could uncheck it at this stage. And then that's the last thing we have to do. Now, when you hit this OK button, it's going to magically create our repository on github.com. So let's click OK. And it says publishing to GitHub, uploading files. For some reason, it's not allowing me to publish the new GitHub repo from this new account that I created. So now that I've shown you how to create a new account on GitHub, I'm going to sign back into my old account that's part of my name, Eric Loff, and hopefully I can get it to work with that account so we can continue on with setting up our new repository. So I will be back after I sign in to my older account. Okay, I'm back. I had to sign out of my new account that I had created, the Joy of Ray Tracing account, and sign back into my old account that I had before, which is Eric Loff, which is part of my name. So it wasn't working for some reason for me to have two different accounts on VS Code and it trying to publish to two different accounts on GitHub. So I think it got messed up a little bit. So I'll still be able to show you everything that you need to do in order to get your repo set up and all the options on github.com. But I'm just going to publish it under my own name now. And so you can follow along with me still. So publish to GitHub. And then I'm going to make it public, as we mentioned before. But now you can see it's under Eric Loff. It's my older one that worked. So I'm going to try this one, public. And then I want all the files and folders. And hit OK. All right. It says successfully published the Ray Tracing Projects repository to GitHub. So success. Yay. This is what you should see also on your devices. So now we can click Open on GitHub. And look at that. It created a brand new repository just for our project. And it initialized everything for us. We only had to click the button a couple times inside of VS Code. So for those of you who haven't used this before, this option is really awesome. And I would have loved to have something like this back like 10 years ago when I was starting to get into the Git system and the GitHub system and all that. So now we can take a look at our new repository and we can see it has the HTML files. So if you click on the last one we were working on, interactive page, it'll have all the code now. And then likewise, if you go in the JS folder, it'll have the code for the JavaScript that we had written for interactive page. So you can view that as well. And then our CSS folder had the styles information that we wanted for the web page. So there, that one is too. So that's really cool. It gave us the folder structure and all the files that we wanted from VS Code right to github.com. And now anyone with this link can look at your project and try it out if you have some demos, and I'll show you how to do that in a minute. All right, so one of the first things that we can add to this repository, and you'll notice it's missing down here, is a README file. So it says right here, add a README, and that's in the .md format, so Markdown, and it's kind of like GitHub flavored Markdown, and so it's a little bit like HTML, but not quite. So I just used the basics of it to get some text and images on the screen and some links to my demos and things like that. So I don't know a lot about the Markdown language, but I just know the basics enough to get what I need up there on the website. So click add a README. And now it'll fill in this title for you, and that'll appear in large font when people come to your project page for the first time. They'll see that first. And then we can hit enter. Oh, and by the way, we're currently editing this file on GitHub, and all the functionality of Git is under the hood. So it tracks all these changes for you, and it'll keep track of the history of versions of your code. But I prefer to make the changes inside of VS Code, where I have the nice code editor with syntax highlighting and code completion and all that, and then push those changes up to this GitHub account. So, but for stuff like READMEs like this, we can just edit it here. And then I'll show you a really cool thing. When we go back in VS Code, it's going to detect that we have changed something on our repo, and then it'll pull the changes back into VS Code, which will reflect our changes on the GitHub website. So it's really cool. It's all connected. So on line 3, you can just put a description. So this is a repo that holds all of my ray tracing projects, demos, and files. So we're done editing this README file for now. Oh, and by the way, you can see it's called readme.md, and there's that MD extension, which means Markdown, which is GitHub's version of Markdown language. It's a little bit like HTML, but there are some differences. So we're done for now for editing this file, and you can scroll down. Now here's a vocabulary word for Git. It's called commit. So when you commit something to this repository, you're basically saving a snapshot of the whole repository at that exact moment. So we are writing to the history books, essentially. So this text field here is for entering a message about what this commit is doing for the repository. So it filled in create README, but if you wanted to, you can say init README. And then you can add an optional extended description, but I usually don't do that. This little description up here is just fine for most purposes. And now you commit new file. And look at that, it created a readme.md now that lives in our repository. So if we go down here, those changes are reflected. So it says ray tracing projects, that's the name of our repository. And then we have a little description here about what it is. This is a repo that holds all of my ray tracing projects, demos, and files. And so you can change this to wherever you like. I'll show you in a minute how we can put some images in this README, as well as some links to our demos, so people can easily try out your demos that you're going to be making on this video series. So now let's head back to Visual Studio Code and see if we can pull these changes. So over here, you have to look for it. It's kind of hard to see, but there's a little sync button, SYNC, sync button, and it's right here, synchronize changes. So we're going to click that button, and that will check the github.com website, and it'll check your repo if there was any changes recently made. If so, it'll pull those changes into VS Code where you can work on them further and be assured that you have the latest version of your software. So let's click Synchronize Changes, this little bitty circle down here. And it says, it reminds you, this action will pull and push commits from and to your repository. So for instance, if you made changes here, you could click that button and it would push the changes to the remote repository on github.com. But likewise, if it detects that there's changes on the github.com repo, it'll pull those. So there's push changes and pull changes. So we're about to do a pull because it'll notice that there's something new now on the website that we don't have here in our VS Code editor. So OK, and don't show again. So now it looks like it did something. Let's check the File Explorer now. And look at that. A README popped up in the menu here. So click on README. And now this is the same README that we had just created on github.com. Isn't that cool? So now let's do it in reverse. We're going to make a change here and then push those changes up to the GitHub repository where everyone can see them publicly. How about let's add a message to check out some demos that we're going to add in a minute. So check out the live demos below. Okay, so now as soon as I change this file, and no matter how small the changes are, it'll detect that I made a change. And so where the source control icon is, there's a 1 there under notifications, and it says you have 1 pending change. So I'm going to click this, and now look at that. We can commit from VS Code without even visiting our repo on github.com. So again, we want to have a description of what this commit is doing. And although it's really small, and normally you wouldn't do this small of a commit, but this is just for demonstration purposes. So update README. All right. And then all you have to do is click on this purple commit button. So let's hit commit. Oh, and this message pops up. Would you like to stage all the changes and commit them directly? And so you can say always to this. And now all you have to do is click on this purple button, sync changes, and that'll immediately sync all the changes between our VS Code editor here and our repo online at github.com. So let's click on this, sync changes. And that appeared to work. So let's go see if it updated our repo online. Okay, now this is the old message. So I'm going to refresh the page. Look at that. it updated immediately. So this is a repo that holds all of my ray tracing projects, demos, and files. Check out the live demos below. And so your changes are synced from VS Code to your repo online. And it's bi-directional, so you can do it from VS Code and then push the changes, or you can do it from github.com and do the changes there on your repo, and then pull the changes back into VS Code to work on them further. And always right here beside your name is your last commit that you performed. So it says update README, and remember that's the description that I gave it. So if you click on update README, it'll show you the differences, or diffs as they like to be called, between the old file and the new updated file. So you can see here, this one has a minus sign and it's in red. So that means it removed this line. And then this one has a plus sign and it's in green. So that's the new one and the most recent version. And so this added right here, check out the live demos below. That's highlighted in green. So you can tell exactly what has changed from file version to file version. Also, you can see who committed it. So if you were working on a big team, let's say, and you had like 10 programmers working on the same project, I can see that Eric Loff committed this, and I can see when that happened 4 minutes ago. And so you can go back through the history of the project and see who committed what, and possibly like who did what to make something break, or who added what feature, so you can discuss with them further about updating that feature. So GitHub uses the Git system under the hood to do all the branching and merging and diffs and synchronizing changes and things like that. But github.com brings to the table the social aspect and allowing software developers to collaborate together on the same project. And I like to tell you about one more thing before we add some links to our demos online here. For my larger repos, like the three.js path tracing renderer, I've been asked by multiple people if I have a license for it. And by license, I mean just how they can use it, and if they can copy things from it, and if they can use the algorithms that I have in the code. And so how restrictive of a license do I want? And so I've never been much about licensing and all that. And so I wanted to pick the most permissible license possible. And so I'm going to show you how to set that up now, because it's deep in this little menu system and it's hard to find. So you have to go to Insights, and then Community Standards. So it took me a long time to find this. Community Standards. And then it says you have a README already. That's good. But then see, license is not checked. So let's just add a license real quick. And then it says choose a license. So the most permissible one is the Creative Commons 0 universal. So this basically says you can copy and paste my code, you can use it for whatever, you can make money from it if you make another app, you can show it to others, you can share it, you can do whatever you want with it. And also it waives any liability. So if you use my code and your project melts down, well, it's not my fault. So hopefully that will never happen, because my software is not critical software. So, but anyway, let's click on Creative Commons 0. And basically it gives the legal boilerplate of what that all means. And so you can just hit review and submit. And so this is actually adding a license file to our repo. So this is technically a commit. So you'll see down here, if you scroll down, commit, new file. And it already filled in the description, and we can just keep that description. It says create license. and then click on Commit New File. And then it gets a little weird here if you've not seen any of this GitHub stuff before. So you're actually opening a pull request on yourself, on your own project. So it says the change you just made was written to a new branch from the main branch, and it's named add license. So do you want to merge this? And so what that'll do is just merge these changes into your main branch, which is the main project that we have. So we just want to say yes, create pull request. Before you click this button here, you can just check what files have changed. So files changed, and it shows you that it added this, because it's in green, it shows you that it added this license to your project. So go back to conversation. And then all you do is click on merge pull request. And then it'll say confirm merge, are you sure? So let's hit confirm merge. All right, the pull request successfully merged and closed. And so now you can safely delete this branch because we no longer need it. It's already been rolled into our existing code base. So you can hit delete branch. And now we're good to go. It says up here, create license has been merged in purple there. So now let's go back to ray tracing projects, our main page for this repo. And we'll notice that a license is now there. So anyone who comes to your page from the outside and is wondering what they can do with your code and how much they can use it and what's the permissions of copying your code and things like that, basically you just say, well, if you look at this license, it's the most permissible one. It's right here. It says the CC0 public domain dedication waives copyright interest in a work you've created and dedicates it to the worldwide public domain. So that basically says y'all can do with it whatever you like. So go back to code, and in our most recent commit was a pull request merge. And if you click on that, it reminds you what you did just a moment ago. So we can hit back. Okay, now if we want to have visitors to our repo here on GitHub be able to click on a link and then run a demo that we've been working on, we need to set up one more thing inside of GitHub, and that is called GitHub Pages. And GitHub Pages is the system that GitHub uses to host your repository for free. So let's set that up now. Click on Settings. Go over to the left side of the page and click on Pages. So now it says GitHub Pages is designed to host your personal, organization, or project pages from a GitHub repository. And it does this for free, so this is a really cool feature. So if you see down here, it says GitHub Pages is currently disabled. Select a source below to enable GitHub Pages for this repository. So now let's click on this button here and then click on Master. And if you click on Save now, it says GitHub Pages source saved. Now, it might take a couple minutes for GitHub to actually start serving your website. So you can check on it by going back to Ray Tracing Projects and then click on Settings again. And then click on Pages. And yay, look at that. It says your site is live at this URL. And it should have the name of your repo right here. So let's click on that. I'll open it up in a new tab. All right, so now we have our own web page. Isn't that cool? So it says it has the README that we had written earlier, and then this site is open source. So it's letting you know that the code is freely available and you can view it and there's no restrictions. So let's go back to our repo here. And now that this is being hosted for free, we can actually make a clickable link to our demos that we have been working on in the last couple of episodes. So let's try that now. So go back into ray tracing projects, which is the main page for our repo. And now we can edit this again, this readme.md. And so if you click on the edit icon, hit enter and go on to line 5. And now we're going to create a line break tag. So do you remember how to create tags from our very first episode? So it's left angle bracket, and then the break line element is BR. So BR, and then close it up with a right angle bracket. Hit enter a couple times, and then now we're going to do another tag called a heading tag. So this one is left angle bracket, H, and then try H2. That'll render it in a pretty large font size. And then right angle bracket to end the opening tag there. And now we put our content inside. So live demos. And now we have to close this heading element by putting the closing tag on it. So that is left angle bracket / H2 right angle bracket. And then hit enter a couple times. Or actually put another line break here. So left angle bracket, BR, right angle bracket, and then enter. And we're going to place all of our links right here. So let's go look at the preview. And see, that's pretty cool. It has the title of our repo here, Ray Tracing Projects, and it has a short description of what it's about. And then below here it says live demos, and here's where we're going to put the links to the live demos so people can try out all your cool demos. So now go back to edit file. And remember, our site is being hosted at this URL. It should be your username.github.io and then / ray tracing projects or whatever you called your repo, and then another /. And now here's where we're going to put the actual HTML document file name. So I think we had, the first one was named my webpage.html. And so let's hit enter now and see if it goes to that page. Whoa, isn't that cool? So we are on GitHub's servers and it's serving our entire project, and we can share any of these demos by just putting the HTML file name right here. So let's copy this now. So Control C and go back to our README file that we're editing. And now how links work in Markdown, or this MD extension, is that you do left square bracket and then the name that you want to appear in the text. So my web page. And that's what people will see when they go to click the link. Then you close it with a right square bracket. And then opening parenthesis. Now we're going to hit Control V, and that's going to paste in the URL to our live demo. So Control V, and then close it up with a closing parenthesis, like that. So now if you go to the preview, oh, and one more quirk about Markdown or MD format is that it doesn't like when you have something like this right underneath a line break. So let's erase the line break and then check our preview. That should show up the way we want it to. Great. So now it says my web page, and that's a clickable link. And then it has a short little description about what it does. So now let's do that for the other demos as well. And if you recall, they're called My Web Page, which we just did. And then let's do one for Style Canvas and Interactive Page. And that'll cover all the demos that we have so far. So now just hit enter here, and then another asterisk, space, left square bracket. And this one's called Styled Canvas. Right square bracket, opening parenthesis. And now we have to go and get that URL from our hosted website on GitHub. So this one should be Styled Canvas, capital C. Hit enter just to make sure. Cool. All right, there it is. And so you can click in here, Control C, go back to your edit, Control V inside the parentheses, and now closing parenthesis, and now give a short description about what the demo does. So uses CSS to make the canvas full screen. Okay, and then let's hit enter one more time, and then now let's do another asterisk. And our last one was interactive page. So left square bracket, interactive page, right square bracket, opening parenthesis. Now go back to our live demos URL and change the HTML document name to our last demo that we were working on, interactive page. Enter. Okay, and this one you can click the mouse anywhere, so it's interactive. And you can resize it too. Okay, so let's copy this URL, Control C, go back to your README file, and then Control V, and don't forget to close up the parentheses, like that. And now we should be good to go. So let's commit this file now. We can change this to added live demos. And then commit changes. Okay, so let's go back to our main page, which is the title of the repo, Ray Tracing Projects, or whatever you named it. Oh, we forgot a description. So click on the edit icon again, and then click after here and say uses add event listener to make page interactive. Okay, and then we can just leave this here, update README, that's fine. Commit changes. Now everything should be looking correct. So go back to Ray Tracing Projects and view our finished product now. Now we have the title of our repo, a short description on what it's about, and then we have a live demos section, and with 3 bullet points, and those have clickable links and a little description about what each demo showcases. So that's really cool. So now we got, let's try them all out now. So I'm going to click on my web page, Yay. All right, hello canvas. Let's go back. I'm going to click on Style Canvas. That takes us there. And this one just makes it full screen. It's not interactive yet, so I can't click. And then finally, let's do Interactive Page, which does allow you to click. And you can resize the window, because it has event listeners for the mouse and event listeners for the window resize event. Great. Let's go back. So anyone that has this URL or comes across it by like a Google search or something, they'll be able to try out your demos here. And then if they're interested to see how they work, they can look at the source code for these demos and see how you did it. So I think that's really great. And it promotes sharing of information across the software industry. And so if you want to learn more about a certain technique like ray tracing or HTML or CSS or web programming, you can go onto someone else's repo and look at their source code and try out the demos and use some of that in your projects. And likewise, if someone else comes across your project and you've recently made some cool demos or some discoveries of your own, then they'll be like, oh, cool, I gotta grab that and see how that works. And so they can see your source code and then use your techniques as well for their own projects. All right, before we head back to VS Code, I'm going to show you how to do one more thing with the README file, and that is how to add an image. So if you notice here, we don't have any images yet. And if you look around the repos of GitHub, you'll notice that most of them have some kind of images in their README files. So how do you do that? Well, the answer is it's really easy. It's just a drag and drop. So let's try that now. We're going to pick a random image off the desktop. So I have this image here that shows a ray trace scene of different size spheres with reflections and depth of field and other cool image effects that you can only get from ray tracing. So I like that image to be on my README, so when people come to my repository on GitHub, then they can see that right away. And it goes along with the theme of my repository because it's all about ray tracing. So why not have a ray tracing image, right? So now we can click on the edit icon one more time. And now go to where it says ray tracing projects, click on the end of that line and then hit enter a couple of times. And all we're going to do is literally drag this image right there and just drop it into the browser. So like that, and you'll see it comes up plus copy. So let's do that. And look at that, it automatically uploaded it and placed it right there in our README file. So now I'm going to maximize this window again, and let's check the preview. Isn't that cool? So it has our title of our repo and then a nice image to grab the viewer. And now it explains what this repo is about. And it says, check out the live demos below. And here they are, live demos section. And then you have all the clickable links there. So our README is now complete. And by the way, by the end of this series, we're going to be able to do images like this, I promise. So one last thing for today's episode, I always like doing at least just a little graphics programming on every episode just to keep our skills sharp. So let's go copy our last HTML file that was called interactivepage.html. And let's add a simple button to our web page that you can click on that will randomly change the height and width of all the rectangles on the web page. So let's go back into VS Code now. And first, before we start working on anything, let's synchronize the changes from our GitHub account, because we just changed a whole lot of things over on the README file on our github.com repo. So let's get those changes reflected on our code editor now. So go down here where it says synchronize changes, and it's this little circular button right here on the bottom left corner. Click that. And look at that, it updated the README to what we had just typed in on the website over at github.com. So now let's go back into the File Explorer and go to interactive page.html to make sure that we're in the root folder. And now click on New File. Let's call this one Simple Button. .html, and then hit enter, and that'll create a new file called simplebutton.html. Now you'll notice something new, that this turns green, which means we're making changes to this repo on our code editor here, but it hasn't yet pushed those changes to github.com where our repo is online. So we'll do that when we're ready, when we've completed this demo. We'll push those changes up to our repo in the cloud. Now go into interactive page and select the entire code for that. Control C. Go back into Simple Button and Control V. Now click on interactive page. And again, click on New File to create a new file in the JS folder. And we're going to name it Simple Button also, but it's going to have a JS file extension. So Simple Button.js. Okay, and then in a similar manner, go into interactive page. Now you can, if you don't want to select it with the mouse, you can do this, selection, select all. That's a quick way of getting all the text selected in your code. And then Control C. Go to simplebutton.js and Control V. And just to make sure we don't accidentally change one of the older files, let's click out of interactivepage.js and click X on interactivepage.html. And now we're just left with the files that we need to work on. We can leave README here in the styles.css here for now. So let's go back and change the title first on this HTML document. So erase this text here and then Simple Button. Okay. And likewise, it needs to find the matching JS file, which is called simplebutton.js. So again, we're going to see one of my favorite features of VS Code. It's going to fill in the file name for us. So erase all the text to the left of this quotation mark until you get to JS, and then type /. And don't you just love it? It shows you all the files. So let's click on Simple Button, and it fills it in, and we're good to go. Now, to add a button element to this page, we actually need to create it on this HTML file. So how you do that is click to the right of canvas and then hit enter a couple of times. Now, buttons fall under the input element. And so an input element is called an empty element because it only has one tag. It doesn't have an opening and a closing tag like Canvas. You see, like Canvas has a opening tag and a closing tag. Well, input elements are empty elements. They just have one tag. So type left angle bracket and then start typing input. And then it should come up. Click on that. And now don't close it yet with a right angle bracket. We're going to enter in some information. So we're going to give it an ID, just like we did all our other elements. So click on ID, and that'll fill in the code for you. And inside the quotes, let's call it my button. We'll just stick with that convention. So we got my text, my canvas, now my button. And then now we're not quite done yet. We have to do two more things. So we have to specify what kind of input is it, because there's different kinds of inputs. There's sliders, there's buttons, there's text input. So let's specify that the type, so click on type, is button. You can click button here. And then one last thing we need to put in here is what is actually going to be displayed on the button itself. What text do you want it to say? So you could say like, click me or click here or something like that. But I'm just going to put click to randomize, and that'll randomize all the rectangles, and we'll add the code for that later. So how you do that is you type value, and the value refers to what text is going to appear on the button itself. So click on value, and that again fills in the quotes for you and the equal sign. And then we just put the text that we want to appear in the button. So click to randomize. Don't forget to close up this tag, so it needs a right angle bracket. Okay, so that's all we need to do with simplebutton.html. Now we do have to make one small change to styles.css, because remember, this is using also the styles.css file, just like all our other demos are using. And that's one of the advantages of having an external style sheet like this, is that all the demos that you make can just pull from that same styles file. So let's go into styles.css, and we're going to get a reference to my button that we created on the HTML document. So much like we did for my text, we're going to do that for the button as well. So let's click down here and then hit enter a couple of times. And now the hashtag symbol, my button. And that'll get a reference to my button element, and then hit enter. Left curly brace, it'll close it up for you, and then hit enter. I'm going to scroll up here so you can see it. Now in the same manner as we did for my text, we're going to give it a position of fixed, so we can just copy this. Enter. And I want this button to appear in the lower left corner of the web page. So let's specify a distance from the bottom of the page. So put bottom, colon, and then let's click on the percent option, and then push the space between the colon and the 0 there. And now let's change it to 10% from the bottom. And then don't forget the semicolon. Hit enter. And now, quickly looking back at this simplebutton.html, this text right here, click to randomize, we're going to specify what size we want that to show up as. And that will increase the button size as well, because the button has to surround the text. So under styles.css, let's do font size extra large, just like this one for my text. So control copy, and then paste it in there. Okay, so now let's go back into simplebutton.html, and we're going to run our live server now and just test this out on our local machines. So click on go live, and we'll see if we can see the new button on our web page. So go live. All right, there it is. So we have a new button, and it says click to randomize. Now, if I click on it, nothing really happens because we haven't added any code to handle when the user presses this button. But our mouse clicking is still working, so you can see you press the mouse. But the button doesn't do anything right now, but at least it's showing up, and so that's a good sign. So now let's add some functionality to this button. And that's where JavaScript comes into play. So you go in the simplebutton.js file. And remember how we got a reference to the text element by calling document.getElementById and then putting the ID of our text in the parentheses and then sticking the result back into our variable called text. We're going to do the same for the button now. So let's try that. Click right past this right curly brace and hit enter a couple times. And now we'll create a new variable. Let button equals document dot get element by ID. There it is. Click on there. Opening parenthesis. And then we called it my button. So quotes my button, capital B. And then don't forget the semicolon. Now we have a reference to my button on the web page, and we can manipulate it now with JavaScript. So hit enter. And remember how we added an event listener to the window object to listen for mouse clicks? Well, now we can add a listener to the button element itself. So in the DOM API or the document object API, every element comes with the built-in capability of adding an event listener to it. So that's what we're going to do now with the button element. So call button dot add event listener. And it should pop up here. Click on there. Opening parentheses. And now remember, we put the event we want to listen for and then the function that we want to call when that event happens. So let's listen for a click event. So type quotes and it'll close it up for you. Now start typing click and it should pop up. Click there. And now one more parameter. So separate it with a comma. And now we specify the function that we want called when this event happens. So let's call it handle button click. And we haven't written that function yet, but we're going to do it on the next line. So don't forget the semicolon because this is a statement in JavaScript. And now let's define that handle button click function. And so you remember how to do that, right? So keyword function, handle button click, and it pops up right there because it knows you just typed that a moment ago. And now all functions take parentheses. So opening parentheses, and it'll close it for you. This one doesn't need any parameters inside. So enter on the next line, and then opening curly brace, and it'll close it for you. Now hit enter. I'm going to scroll up a little bit so you can see better. So what do we want to do when the user clicks the button? Let's add some code for changing all the rectangles' height and width by a random amount. So as you recall, rectangle width was here and rectangle height was this variable. So rectangle width equals, and we're going to use the math object that we discussed last time on the JavaScript episode. And so JavaScript comes with a pre-built-in math library or math object that we can use. And so we're going to call that, and then you type capital M, ATH, dot, and then we're going to use the random function. So type random, and then there it is, and it says it's a method, as we talked about on the last episode. So random, and since it's a function or a method, it does take parentheses. So open parenthesis, and it'll close it for you, and it doesn't take any parameters, so you can just leave the parentheses empty. Now math.random will return a number between 0 and 1 with a fractional part to it. So it might be like something like 0.027 or 0.8642 or 0.6923. So it's somewhere between 0 and 1. So we need to scale that little number by an amount that's able to be visible on screen for the rectangle. So let's try times 200. And so if math random comes back with a really small number, it'll be close to 0 or 1. And if it comes back with almost 1, it'll get multiplied by 200 and come back as a width of 200. Now, if it comes back really small, it might, even after this multiplication, it might be too small to see. So let's put a safeguard in there of a couple of pixels. So let's add to this value 5 pixels. Just as a safeguard in case the random number generator comes back with a really small value close to 0. We want to guard against that, and so the user will be able to see the rectangles still. When using the Canvas API, the coordinates should be specified as integers. It can be less performant for the web page if you give coordinates that have fractional parts to them. So let's just round down this number to the next integer. And the way we do that is the math.floor function. And we saw that briefly on the last episode when I was giving you the tour of JavaScript in the browser console. So rectangle width equals math.floor. And it's a method, so it takes parentheses. Now this one does take a parameter, and that's the number that you want to round down. We want to round down the rectangle width itself, so we're going to put that inside the parentheses. So open parenthesis, and then type rect width again. And then it is a statement, so semicolon. So now we have rectangle width equals a random number times 200 to scale it up, and then plus the safeguard of 5 pixels just in case it comes back really tiny like 0 or close to 0. Then we take whatever that is and floor it to the next integer down. So we put that in the parentheses here, and it gets stored back in rectangle width. Now rectangle width should be a nice whole number that the Canvas API likes working with. One more thing we must consider is that half rectangle width uses that rectangle width in its calculation. So it takes that and divides it by 2, and then it puts the result back in half rectangle width. So we have to update this as well when we change rectangle width. So now all we have to do is just select this text right here after the let. So at half rectangle width all the way through the semicolon, and then control copy, control paste. And now we have the updated half rectangle width as well. And then what's cool is we can take this whole section of code and copy it, hit enter, and paste. And now we just change the W's to H's, and we'll take care of the height of the rectangles as well. So change all the W's to H's. Now everything should be correct. So we have rectangle width equals a random number times 200 plus 5. Then rectangle width gets rounded down to the next integer with the floor function. And then the half rectangle width, which depends on rectangle width, gets updated by dividing rectangle width by 2. And then we do the same for the height. So rectangle height equals also a random number times 200 plus 5 as a safeguard. And then rectangle height gets floored to the next integer down. And then half rectangle height, which depends on this variable, gets updated with the new rectangle height divided by 2. And now one more thing before we leave this function is that when we change these values of rectangle width and half rectangle width and rectangle height and half rectangle height, notice that those are used in the draw function. so we need to redraw the screen. So let's hit enter a couple times and then call the draw function. And it is a function, so it takes parentheses. And then it's a statement, so a semicolon at the end. All right, so let's go see if that works. So go back into simple-button.html, and we see our button down here. It says click to randomize. And when you click on here, it should randomize the height and width of all the rectangles on the page. So let's try it. Ooh. Well, it did something. And I purposely left it like this so that you could see one of the missing elements. It is in fact changing all the rectangles, but it is overwriting the old rectangles with the new rectangles, and it doesn't delete the old rectangles. So what we need to do is clear the entire screen. And so that just requires one line of code. So let's go add that now, and then it should be all working perfectly. So go back into simplebutton.js and go inside the draw function, and then click to the right of this opening curly brace and hit enter. And so now on the first line of the draw function, we're going to add a line of code to clear the entire canvas. And the function itself looks very much like this context.fillRect function. So type context. And now what we want to call is called clear rect. So clear, capital R, and it's a function. And then now you can see what it takes. It's an X location to start, a Y location to start, and then how far you want to go in the width and how far you want to go in the height. So since we want to clear the entire canvas, we're going to make this clearing rectangle the size of the entire canvas itself. So let's start at 0, 0, which is the top left corner of the browser window. So 0, 0, comma. And now the width should be the entire canvas width, and the height should be the entire canvas height. So just type canvas.width, comma, canvas.height. And then it's a statement, so don't forget the semicolon, and then hit enter maybe just one time to put it on its own line. Now each time we call the draw function, it'll use a clearing rectangle of the entire width and height of the canvas to clear the canvas. And then it'll draw the new rectangles that we've specified. It'll also draw the new rectangles that are randomized when we click the button. So now let's go back to our web page and see the final result. So we have our rectangles. We can click the mouse. We can resize the page. And now let's try out our new button. So click to randomize. Good, that's working. Now let's see if it updates it. All right. So each time it comes back with a random width and a random height, and it copies that 5 times for all the rectangles. So we can do that as many times as we like. And you notice when it's very thin that our safeguard comes into play. So that 5 pixels makes a difference when the number comes back really small. That way you can see them all the time, no matter how small they are. And likewise, we can resize the window and the dimensions of the rectangles will stay the same, no matter what we do to the window. Randomize again. Let's try that shape. So full screen, restore down, try to squash it. No matter what we do to it, the rectangles keep their shape and keep their dimensions. All right, the last thing we're going to do today is take those changes that we've just done with our local repository and push those changes to the GitHub Cloud repository. So let's go back into VSCode. And now you notice over here it has 3 notifications or 3 files that have changed. And so that refers to styles that we changed for adding the My Button element. And then we changed simplebutton.html and we changed simplebutton.js. We created those files, and just by creating them, you're creating a change in your repo. And so Git under the hood notices that and keeps track of all those files for you. So now we're going to commit these changes. So let's try that. So click on 3 pending changes here. And then we want to describe what this commit is doing. So add button demo. Now we commit to save. Okay. Now once we've saved on our local machines, we push the changes by clicking this sync changes, and that'll immediately reflect the changes on our matching GitHub repo on github.com. So let's click sync changes. This is my favorite part because this whole process used to be so tedious, and you used to have to go into the command line and type all this stuff to get all this to work. And now with this new feature from VS Code, it's literally just like 2 clicks and you're all set to go. So now let's go back into our repo on GitHub and click on Ray Tracing Projects. Oh, I forgot to save these changes that we had made. So edit file and commit changes. So now click on Ray Tracing Projects. And look at that, there's our new demo. simplebutton.html. And now we want to add that to our live demos. So now let's go into our hosted web page, which is yourname.github.io/ whatever you named your project to be, / then the title of the demo. So click in here and erase interactive page. And let's try Simple Button now and see if it's working. All right, cool, there it is. So we can click on the button now and it's working perfectly. So let's take this URL and paste it into our README so that you can provide a link to this demo as well. So click in here and then Control-C. Go back to your README and click on the edit icon. And we're going to do something much in the same way as we did these demos here. So click over to the right of interactive and then hit enter. And now type asterisk for another bullet point, space, left square bracket. And this is the text that will show up for the link itself. So simple button input. And then right square bracket. And now opening parenthesis. and then the URL goes inside, so Control V, and that's the link to our demo. And now type closing parenthesis. And now let's add a short description about what this demo does. So adds a simple button to randomize width and height of rectangles. All right, and then you can just leave the commit message as update README that it filled in for you. That's fine. Now let's commit changes. Go back to ray tracing projects, the main page. Now you should have your beautiful image here. Oh, and by the way, this image is freely available from Wikipedia. So if you search up ray tracing or path tracing in Wikipedia, you'll be able to download this image and use it as well. And now we should have our 4 demos in their entirety. So we have my web page, style canvas, interactive page, and now we have simple button input. So let's try to click on there. And we're taken to our new demo. We can click the button and it works perfectly. Now just real quick, go back into VS Code and remember to hit the little sync button down here. It's the circular button on the bottom left corner. So click there. And that should update your README. And yes, there it is. Simple button adds a simple button to randomize width and height of rectangles. Now our changes are synced on our local machine here, as well as our repo on github.com. So I think that's really cool how it's all integrated now inside of VS Code, and you can actually just stay inside VS Code and make all these changes and then just push all the changes to your repo automatically. It's a really cool feature that they added. Well, I hope you enjoyed that today. So we did a lot again on this episode. First, we learned what Git was and GitHub and how they're related and how they're different. And then we took a look at how to sign up for a new account on GitHub. Then we created our first repository right from the environment of VS Code. Next, we took a look at how to maintain and update our repos, as well as add images and links to live demos on the READMEs of our repositories on GitHub. And finally, we added a cool new demo that showcases a simple button element that randomizes all the rectangles width and height on the web page. So moving forward, each time we make a new demo or add new code to our projects, we can push these changes from VS Code to our matching repository on GitHub, and we can have a place where we can store all of our project code and have a backup in case anything ever happens to our local machines. And also, by having it on GitHub, we can easily share our projects and our demos with others online. So we're almost at the end of Chapter 0. The next episode will be the final episode of Chapter 0. And on that episode, I'm going to tie up some loose ends and go over some things that I failed to mention on previous episodes. And some of those things are related to the JavaScript programming language, simply because it's such a big topic that I couldn't quite get to them all in the last episode, even though the last episode was really long. Also, I wanted to show you just a couple more things about the live server plugin and how we can connect different devices to your computer that's running live server so that you can run these demos on a tablet or your cell phone, any device that's connected to your Wi-Fi. You can run the demos on those devices as well. So I'm really excited for the next episode simply because it's the last episode of Chapter 0. And then when we finish that one, then it's time to move on to Chapter 1, where we'll start actually talking about ray tracing topics and making our ray tracers from scratch. So I'll see you on the next episode.